Hello and welcome to another episode of GSC at Home Destination Space Week. My name is Natalie and today we're going to be looking at the next big space telescope, the James Webb Space Telescope, or the Webb Telescope for short. As an astronomer, I love looking at space from Earth. We've been using telescopes on the ground for over 400 years to look out into the universe. But on Earth, things can really get in our way when we're looking up into space. Our atmosphere can make things look really blurry, and sometimes we just don't have the patience to wait until nighttime to make our observations. Can you think of anywhere with no atmosphere and no daytime or nighttime? Space. We've been sending telescopes into space for over 50 years, and my favourite, the Hubble Space Telescope, has been orbiting Earth at a height of 568 kilometres since the year 1990, and in that time has taken some truly breathtaking images. But technology has changed a lot since the 1990s, and it is time for a new kid on the block. The Webb Telescope, named after James E. Webb, who was an administrator at NASA and led the Apollo program that put astronauts on the moon. Like Hubble, the Webb Telescope is a collaboration between NASA, the European Space Agency, and the Canadian Space Agency. The Webb Telescope is going to launch in 2021, and it's going to see a lot more than Hubble can. If you've ever passed light through a prism, or seen the reflection of a CD, or seen a rainbow after a storm, you'll know that light can be split up into all the colours of the rainbow, with red at one end and violet on the other. This is called the light spectrum. Light that we can see is called visible light, but there's lots of different types of light that we can't see. Just beyond red in the spectrum, there's a light called infrared that we can't see, but you can detect it with a thermometer because infrared is given off when heat is given off. And if you measure the temperature of the spectrum, you can even see that just beyond the red is the hottest part. That is where infrared is because it's giving off heat. We can't see infrared, but lots of animals can, and even our cameras can. You can even test this at home just by using a simple TV remote. If you press a button on a TV remote and look into the emitter, you just can't see anything. But if you take a camera, like I have my phone camera, and look at the light through the camera, you can see there's actually a light given off. This is because our cameras can detect infrared, but our eyes can't. You might even be able to see, through my camera, a little infrared light being given off, but I can't see that in real life at all. The Webb Telescope is going to be able to look at the universe in infrared. This is why it's really important it's in space, because infrared can't get through our atmosphere. But infrared does travel further through space than visible light. This means that Webb can look really far into space and see some of the oldest things in the universe, which is really exciting. Let's have a look at some things in visible light and infrared light. Look how in this nebula, the infrared can travel through this dust cloud that the visible light just can't. And look at this galaxy. You can see way more cool things in infrared that you can't see in visible light. So how is the Webb Telescope going to collect all of this light? Smaller telescopes use curved pieces of glass called lenses to collect and focus their light, like in our glasses or in our cameras. But big telescopes need mirrors to collect and focus their light. Mirrors in a special shape that look sort of like parts of the inside of a sphere. This is called a concave shape. Now, Webb can't use one big concave mirror though, because it would be far too big to be able to get up into space on a rocket. It needs to use a mirror made of smaller shapes that make that concave shape. So, which shapes should we use? To investigate this, I have made 3 models of mirrors out of card using 3 different shapes. I've made one out of squares, one out of circles, and one out of hexagons. We want to be able to make sure that we can make a concave shape out of our smaller shapes. But we also need to make sure there are no gaps left in between because we want to reflect as much light as possible. Now I can see here that my squares leave very few gaps in between. Let's try and see if we can make these into a concave shape by putting them inside a glass bowl. Now here, I've made them into a concave shape, but they don't look really very happy about it. These squares are having to overlap with each other, they're leaving lots of gaps, and they don't seem to be wanting to make this concave shape at all. So let's try something else. I know what will make this concave shape. Circles. These circles fit this concave shape perfectly, but they leave lots and lots of gaps in between them. This would let through far too much light, and we want to reflect as much as we can. So let's try something else. How about hexagons? These hexagons fit this concave shape perfectly, and they don't leave any gaps, so we're reflecting all of our light. So hexagons are the perfect shape to use. Here we can see the real mirrors for the Webb Telescope, which fold in at the sides for launch and come out when it's ready to start taking observations, 1.5 million kilometers from Earth. The real mirrors are much bigger than my model though, at 6.4 meters across. That's bigger than a car. It looks like it's riding a cool hoverboard across space here. This is a sun shield. We said that infrared is given off when heat is given off, and we want to make sure that the only infrared that the telescope is receiving is from space, which means we need to keep our mirrors really cold, and the sun shield does this. It keeps them at minus 233 degrees Celsius and makes sure that the sun doesn't get in the way of our observations. There are also solar panels underneath it, which means that the Webb Telescope gets all of its energy from the sun. So I hope that you're as excited as I am now about the launch of the Webb Telescope in 2021. I know that I'll be watching it with a bag of popcorn. If you've got any questions about today's episode, please let us know, and we'll see you again next time.